boys and girls, here we are, chapter 12, lesson 5. And this lesson always kind of throws me for a loop. We're like converting measurements and doing all this work, and all of a sudden they're like, hey, let's do line plots. But yeah, whatever, we'll do it. We'll do line plots. Okay, chapter 12, lesson 5, line plots. Okay, so line plots kind of have three parts to them. You get a little table of data. You have to organize it into this nice chart, and then you build a line plot from that. And people use line plots so that they can just glance and see how much there is of something without really studying it. That's why people make graphs a lot, so you can just kind of get a sense of what's happening without looking at a really confusing list like that, right? Okay, so it says, number 1, some students compared the time they spend riding the school bus. Complete the tally table and line plot to show the data. Okay, so here is the info we need to look at first. And it looks like they kind of helped us out, didn't they? They started off with the 1/6. So I like to do this. 1/6, 1/6. They have already put 2 tally marks in there for each of the 1/6 hours spent on the school bus. Okay, so really what I like to do then is go kind of one by one. Okay, so I'm going to go 3/6. I give a tally right next to 3/6 on the tally table, and goodbye 3/6. The next one's 4/6. Give a tally, bye-bye. 2/6. Tally, done. 3/6, tally, done. They already did that 1/6 for us. Oh, and there's another 3/6. So 3/6, there you go. And then the final 3/6, and farewell to you. Okay, so our tally table is complete. So we use the information from the tally table to make the line plot. The arrow is, oh my gosh, what does that even say? To make the line plot. That's better. Good gravy. So this is the line plot, guys. Okay? So they have already started it again. They put the X's right above 1/6. So when you look at 2/6, how many tallies did we put by it? 1. So 2/6 gets 1x. One child spends 2/6 hours on the school bus. Let's go down here to 3/6. That got 4 tallies. So 1, 2, 3, 4. Each of those X's stands for a kid who spends that much time on the school bus. And then we go to 4/6 hours. Only one kid spends 4/6 hours on the school bus. So there is a completed line plot. Okay? So we have to answer now questions 2 and 3 about this information we just plotted. It says, how many students compared times? So basically, how many students shared the time they spend on the bus? Well, there are 3 different places we can figure that out. We can count the tallies here, we can count the numbers there, or we can count the X's on the line plot. So I'm going to count the X's on the line plot. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. How many students compared times? 8. Because remember, we just said every one of those X's stands for a student who shared what fraction of the hour they spend on the bus. All right, let's look at number 3. What is the difference between the longest time and the shortest time students spent riding the bus? Okay, what is the difference? What is that in your head? Ring, ring, ring. What operation goes with difference? The answer to subtraction, right, is difference. So what's the difference between the longest time? What's the longest time? Okay, it's 4/6. 4/6 is the longest. We have to find the difference between the longest and the shortest, which is 1/6. So 4/6 minus 1/6. Very nicely, they have the same denominator, right? So that doesn't change when we subtract. So we go, let's see, 4 minus 1, 3. Okay? The difference between the longest and the shortest time is 3/6 hour. Okay? That's the same as 1/2, isn't it? So the difference is a ½ hour. That's a long difference. So there you go. There's the line plot. We only have a few slides on this one because just on this we did 3 problems, didn't we? All right, let's keep going. All right, here we go. Number 5 directions say for 4 through 5, make a tally table on a separate sheet of paper. Make a line plot in the space below the problem. Okay, so it says tally table on a separate sheet of paper. Well, I don't have paper on here, so let's make a tally table here. And you guys, you can maybe squeeze it in on your workbook page, or maybe you have a sheet of notebook paper, right? All right, so let's see here. I'm going to use the numbers down here to help me make my tally table. Okay, so I'm going to do, oh, I guess I need a title. The title's right here. Distance, I'm going to have to abbreviate. Between stops. Now, on yours, write for a rural mail carrier. Write the whole thing, okay? And it says in miles. So this is going to be miles. Okay? And then the other part is going to be for the tallies. So tally. So you guys copy this groovy title up here. Okay? I just don't have space. So that's the title. And then the first column is for miles. And the second column goes with the tallies. So like I said, I'm going to use these numbers to help me with my tally table because they have them already nicely in order. So the mail carrier, some of them go 1/10 of a mile. Some go 2/10 of a mile. Oh, this is the difference between stops. Between, that's a long drive between stops. That's not how it is in my neighborhood. 3/10 of a mile between stops. 4/10 of a mile between stops. And I'm going to have to make another section for 5/10 of a stop. I mean, 5/10 of a mile between stops. Okay? So you can pause this and make your tally table if you want to, if you need a second to do that. But I'm going to start, just like I did before, looking at this list and tallying. All right, so 3/10, 3/10 gets a tally. 4/10, 4/10 gets a tally. 5/10, boom. 1/10, up, boom. Oh, another one for 5/10. 4/10 again. 4/10 of a mile again. Oh, and a 3/10. So look at that. None of these mail carriers has 2/10 of a mile between stops. All right, now let's create the line plot. So 1/10, 1x, 2/10 gets nothing. 3/10, boom, boom. Okay, 4/10, a 1, a 2, a 3, and 5/10. Ta-da! Let me read the directions and make sure we finished everything. Make a tally table, check. and make a line plot. Check. Fantastic job, guys. All right, let's keep going. Oh, so this one, the directions say, is this on the back? Yes, it is. This is on the back, the lesson check. It says, use the line plot for 1 and 2. So this time we're not making a line plot, we're actually using a line plot, okay? Number 1, how many students were reading during study time? So let's see, the title of this line plot is Time Spent Reading During Study Time in hours. Oh, okay. So every one of these X's stands for the hours or the fraction of the hour that the student read. So each X stands for a student's answer to that question. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 students shared how much time they spent reading during study time. Okay, so number 2, what is the difference between the longest time and the shortest time spent reading? Oh, so again, we have the difference, which is an answer to subtraction. So the longest time is 4/8 of an hour minus difference 1/8, which is the shortest time. So very nicely, again, they have 8 as the common denominator, and then 4 minus 1 is 3. So the difference is 3/8 of an hour. Choice B. Fantastic. I think we're going to jump down to review now. Yes, we are. Right here, lesson 6 in chapter 9. All right, let's take a look at this. Bobby's collection of sports cards has 3/10 baseball cards and 39/100 football cards. The rest are soccer cards. What fraction of Bobby's sports cards are baseball or football cards? Okay, so this is a little odd the way that they word this when they say or. It really means together. What fraction of Bobby's sports cards are baseball and football cards? Okay, they want to know if you piled up all the baseball and the football cards, how many would you have? Okay, and what are they doing here? What are they trying to do to us here? The rest are soccer cards. They're just messing with us, aren't they? There is nothing in here about soccer cards. That's just information we don't need, and that happens sometimes, right? They just throw something in there like that. So we are combining the baseball cards, which is 3/10 of them, and the football cards, which is 39/100 of them. So when you just put 2 sets together, that is adding. Right, guys? Just combining these sets of Bobby's cards. Okie dokie. What do we have to do here, guys? We can't just jump in and add higgledy-piggledy because those denominators are different, right? We have to make both of those denominators the same, so let's make them both 100. Okay, so that one already is 100. What's 10 times 10, right? Because whatever you do to the denominator, you have to do to the numerator. What's 10 times 10? 100. You remember this lesson, don't you? 3 times 10, 30. Okay, so 3/10 and 31/100, those are equivalent fractions. They're equivalent fractions. So now we can add because we have 2 fractions with 100 in the denominator. 30/100 plus 39/100. All right, let's do 30 plus 39. 9, 3 plus 3 is 6. 69/100. So baseball and football cards, 69/100 of Bobby's collection. Fantastic. You guys are working so hard. Keep it up. Don't give up.